Hello, I'm Tana, your MLC tutor. So I've been using simplified formulas for the actuarial present value of continuous insurances where we have a constant force of mortality. And I wanted to go ahead and show you where some of those come from. I have a hard time using formulas if I'm not convinced or have some kind of a general sense of why I can use them. So I'm going to show you how they're derived, and maybe that will help you in doing a problem. Okay, so first let's look at the actuarial present value of an insurance on an actuarial payable, a whole life insurance on an actuarial payable at the moment of death. Now remember that when we're calculating the actuarial present value of this insurance, what we're really doing is, say it was a discrete insurance payable at the end of the year of death. What we're really doing is we're finding an expected value. We're looking at all the possible present values of the benefits that we might pay out and their associated probabilities. So maybe they die in the first year, and in that case, if we're looking at a benefit of 1, you get 1 discounted back 1 period, I'll say 1 year, and the probability of that, of course, is QX, you die in the first year. Maybe you live the first year and then die. In that case, you'd get the benefit discounted back 2 periods, okay? And so on and so forth. So to get the actuarial present value, we're going to take all these products and sum them up. Same thing as when you find expected values. For the actuarial present value of the actuarial present value of this insurance on X payable at the moment of death, we're doing the same thing, but now since it's continuous, we're going to integrate so we can add up for all those moments. Okay, we're doing the same thing. So we're going to look at, same thing we're looking at here, we're looking at the probability that they live up to whatever point that we're at and then die in the next year. So in the continuous case, for each possible time t, we're looking at the probability that our x-year-old lives to t and then dies in that next moment. Of course, at any point t, that benefit will get discounted back t periods. We're adding up all these possibilities over the future lifetime of x. Since it's a whole life insurance, it's going to go from 0 to infinity. And we're integrating that with respect to t. Okay, that was a little side note, I suppose. Let's get into what I really wanted to look at, which was how this insurance simplifies down into such a nice formula if you have a constant force of mortality. Okay, so since we have a constant force of mortality, this is going to be e to the negative delta t, that's our v to the t, tpx, the constant force of mortality is e to the negative mu t, then our mu, I'm going to leave off x of t, dt, I'm going to pull out our constant mu, this becomes integral of e to the negative quantity mu plus delta t, integrated with respect to t. Okay, integrating that gives me e to the negative delta plus mu t over negative delta plus mu evaluated from 0 to infinity. I'm going to pull out my 1 over negative delta plus mu. And then we have e to the negative delta plus mu t evaluated from 0 to infinity. Well, e to the negative infinity is 0, and e to the 0 is 1. So we have 0 minus 1, which is negative 1. Just going to cancel our negative over here on the left, and we are left with mu over delta plus mu. Okay, let's do another one. Let's look at how we get that nice simplified formula for the term insurance. So term insurance will be the same as whole life insurance, except you're only looking at times up to time n. So we're going to integrate from 0 to n, but the inside here is the same. Okay, so that will simplify the same as our whole life insurance did, of course, except the limits of integration are 0 and n. Say we get all the way up to the point where we have mu over negative quantity delta plus mu, and we're looking at e to the negative delta plus mu t, but now it's evaluated from 0 to n, so we end up with this is going to be e to the negative mu plus delta times n minus e to the negative 0, which is 1. Okay, and I would just rather not have this negative out here in front, so I am going to make this a positive and switch these around. Or if you prefer to think about it, I'm multiplying by negative 1 here and also here, so I'm just multiplying by 1. And this is going to, your final formula here is mu over mu plus delta times 1 minus e to the negative n times mu plus delta. That's for term insurance. So I'm hoping this is useful for you too, because maybe if you are memorizing those, now you should understand where they come from, I think. That way if you forget it on the exam, you can come up with it again, hopefully quickly. A couple more. Of course, if you're looking at a term insurance, another way to write this is NEX. That's just a payment of 1, or, well, assuming that your benefit is 1, would be a payment of 1 at time n if you survive to that point. So that's just going to be b to the t times TPX is our payment of 1 discounted with interest. I should be using n's. So our payment of 1 discounted with interest n periods if you live to time n. Of course, with the constant force of mortality, v to the t becomes e to the negative delta t, and t's again. I just love t's. E to the negative delta n times e to the negative mu n, which simplifies to e to the negative n times mu plus delta. That one hopefully super easy to come up with on your phone. Excuse me. And then one last one I'll look at for single lives is an n-year deferred insurance. Well, that's just going to be an insurance, n-year deferred whole life insurance, payable at the moment of death. That's just going to be a whole life insurance on X, but n years from now, so X plus n, payable at the end of the year of death. If you reach that point, and then it's going to be discounted back for n periods. So since we have a constant force of mortality, our AX plus N will be the same thing as our AX. It's the same wherever you are. It's a constant. The force of mortality is always the same. So this, like we said before, is just mu over mu plus delta. And then this simplifies down to, as we showed with the term insurance, e to the negative n times delta plus mu.